Well, hi all. My name is Jinan Fiaidhi. I'm from Lakehead University, Ontario, Canada, and I will give a brief introduction to the Maytag Accelerator project, which is entitled Developing the Next Generation Graph-Based Problem-Oriented Medical Record. This project is in collaboration with Thunder Bay Regional Health Science Center, and our collaborator is Dr. Arnold Kim. This project is initiated on the idea of Dr. Lawrence Weed. The idea is started with the birth of the problem-oriented medical record, POMR, and SOAP, which is subjective objective assessment and plan. The subjective is around the information that is taken from the patient, what kind of symptoms he has, what he is suffering from, and all the information related to the disease or to the information that's collected from the patient. Once we have this information, the objective is going into further process by asking for some extra test, lab test, and collect other information from the physician side. So the physician will ask for those extra tests to be done on the patient. Once those information will come back to the patient, he will start the assessment and give plan on how to treat the disease or the problem that is mentioned by the patient. So Dr. Lawrence Weed, the developer of this SOAP node, he's a professor of medicine and pharmacology at Yale University. His challenge was how to document those information coming from the patient or from the physician, how to document it in a structured way. Previously, those information, they were documented unstructured, and it was very difficult to retrieve information or to do query on those information to return back related information to the case of the patient. So here we started the idea behind the Maytags project by incorporating the new technology, healthcare technologies, machine learning, and AI to organize those information that's collected from different locations, from different sites, how to organize it in a structured way. So those information will be useful for the analysis and get extra results from it. So the Dr. Weed, he was before the late of 1960, he was using paper records. Those were not only illegible, but they had no organization. They were not structured, and no common format or structure. You know, if the data does not have any format or structure, then we cannot integrate it with different type of data. We cannot do query on it. So Dr. Weed realized that a record organized around patient's problem could guide diagnostic and critical thinking. Actually, he traveled across the United States looking for a universal structure to medical record, and in doing so, he changed medicine. And remembering Dr. Weed, the father of the POMR and SOAP node and the problem knowledge coupler, this Maytag 2021, which the principal investigator is Dr. Mohammed, and I'm a co-investigator, we organized it and it is dedicated to realizing his dream and arriving at the future POMR record. At this point, I will leave the continuation of this introduction to the principal investigator, Dr. Mohammed, for further discussion around the main idea behind the project.
Thank you very much, Dr. Fiaidhi, for this introduction and in remembering Dr. Lawrence Weed, the inventor or the father of the POMR record and SOAP node. And I would like to say a few things more on our mission. And as I said, Lawrence Weed changed medicine. And in his vision on the problem-oriented medical record and the SOAP node, he envisioned modeling care as a relational vision, where he pictured data to be structured in sort of way like a graph. Everything is nodes and relations. So with his vision on POMR and SOAP, he accommodated various fractions of clinical care, which we call semi-structured data, in one vision, which is so impressive actually up to now. He could embed everything about care design, whether things that comes from patients, from physicians, labs, other assessments and plans, to treat in one what we call upper schema. He used an upper schema, which is the SOAP node, but whatever that can be integrated to it is loosely structured. So this is a wonderful dream. Actually, the problem with this dream is that how you interrogate it later, when your lower data is unstructured, it's very difficult to use things like SQL to interrogate it, because you need a structured data. That's where he tried his best through his lifetime to introduce what is called knowledge couplers to deal with this issue. But he ended into lots of roadblocks where we tried in our vision, this MATAC, to resolve those roadblocks. And the way we design it is to use an idea which is now commonly used, which we called a schema-first design. And schema-first design means we need to use some kind of upper schema, but we need to accommodate whatever unstructured data at the lower ends. And of course, we need a very different API for this. And luckily, the technology did bring GraphQL. So we are using GraphQL to model the dream of Lawrence Weed in that direction, and to connect, even with structured data like HL7 FHIR medical record, which is the interoperable data records standard for the whole world. And this is something very important too. So this is also in phase 1. If I go and try to share some ideas about what is our goal. Our goal is to use that GraphQL to introduce the upper schema. Every case that comes to the healthcare, we will call it POMR case. Could be POMR case 1, 2, 3, 4, and those cases, they could be related or unrelated for a certain clinical practice, and they need to be structured in that upper level through a SOAP schema later, we are designing a front end, and the front end take all that knowledge, structure it, whether creating it or adding to it, updating it through that powerful API that we call GraphQL. Of course, we will need a lot of methods like matching, mapping, and mutations, because data changes, and even it changes on the server. So the mutations is very important part of what GraphQL can do to deal with alterations and mutations of data, whatever they can be. So that's our front end, and we are designing also another component which is called a schema-free backend interface, and that schema-free backend interface actually uses another innovative API which is called New for Java. And of course, in New for Java, we are not only relating all these cases, whatever their structure is, but we are also linking to Dr. Arnold Kim Aurora constellation through this backend interface. Of course, if you ask me what kind of other component this MATAC will involve, it will involve a lot of other agents like the CRUD agent, and the CRUD agent is to create, read, update, and delete whatever clinical cases that is around us. So we have a CRUD agent that do all that querying, creating, and we have another agent, of course, to connect with HL7 FHIR. We call it the bridge agent, and as well as we have very fantastic agent that is so creative, is to let physicians create clinical cases based on POMR through drawing a graph, and that graph will go through GraphQL, then to Neo4Java, and store all that information and that representation. It's very innovative things. Still, this is for phase 2, so we will not talk about it here. But of course, we have another agent which will do a lot of analytics based on graph analytics, like finding the communities where is the concentration, influencing things on others. So you see, when you study graph, when you represent information in a graph, there are very powerful intelligence that come on top of it that goes beyond whatever known now as deep learning and machine learning. So that's part of what we are doing. Of course, if I continue that dream, you will see there are lots of other components that we are adding, but I will leave the details of talking about this project to our associate, Mr. Darien Sawyer. And Mr. Darien Sawyer will tell us lots of things, especially in a tutorial and technical way that tell us why we chose GraphQL for care design, why we are designing a CRUD. What is a CRUD? A GraphQL for care, or what we call QL4POMR, and how do we interface it with the FHIR HL7, as well as what are the benefits that we are going to gain when we implement POMR based on GraphQL. And these are the issues that I will leave to Mr. Darien Sawyer, and I would like to thank you all for listening to this very quick webinar on our MATAC phase 1. Thank you so much. I appreciate your attention.
Hello, my name is Darien Sawyer, and as Dr. Mohammed mentioned, I'm going to be going through our GraphQL-POMR implementation on a more technical level, explaining why we're using GraphQL, what we've done so far with a quick demo, what we're working on right now, and what we're going to be working on in the future. So the main reason that we're using GraphQL to tackle the problems of POMR for design care is because it allows us with a framework to provide a robust schema to semi-structured data, defining relationships between semi-structured data and therefore making it easier to query and navigate these data sets. As well, the flexibility of GraphQL in how you can define different data structures and data types, as well as how you can define your mutations and queries to navigate the data, is very flexible, so it makes it easier to add these new structures if you missed something or you didn't even think of it. And GraphQL as a query language only queries the data that you need because it's very specific. It doesn't pull any information that you don't tell it to, and so it's very nice to not have to navigate any unnecessary data when you're working with it as a query language. So this is a representation of our schema in GraphQL, and as you can see, it revolves mainly around the SOAP node, and this process was developed using the ideas and processes defined by Dr. Weed. So you see the SOAP node branches into its 4 categories: the subjectives, the objectives, the assessment, and the plan. And each of those 4 categories is connected or related to the data types or data structures that they fall under. So subjectives would have data structures like a patient medical history or the encounter details like signs and symptoms. The objective would have information like the lab tests and the vital signs. The assessment would have the diagnosis and how it came to that conclusions. And the plan has information like the follow-up and management of that particular diagnosis. So these 4 categories are connected to a single SOAP node, and multiple SOAP nodes can be connected to a single patient, and that's where it all leads. So when you try to implement this schema into a GraphQL format, you get this. And as you can see now, we have the nodes for patient, SOAP node, and its 4 categories, but there's also information fields, so you can put that information into the specific nodes. So fields for the name, the age, the gender, or things like the family history or demographics. And as you can see, it's flexible in how you can design your schema. Over in the assessment side, we have areas where you can just define or put in the information for your main diagnosis there as a string. Or if you have a lot of different types, like in subjective, you can branch them off to their own data types and store the information there, rather than having both the encounters and the patient medical history both inside the subjective. So now that you have a better understanding of the schema that we're using, I'm going to go through the CRUD agents, that is the create, the read, the update, and the delete agents to navigate this data in a quick demo. Okay, so when you first load up our QL4POMR server, it'll bring you to this front end here. This is the section where you put in your queries, and then the data will be outputted here. And the Data Explorer is where you can get information on the different CRUD agents. The read ones will be within the query. I read here, read all the different types, and find by ID is a special resolver that we have. And the ones that actually alter the data will be in the mutation field. So we have ones for create, and we have ones for updating, and then we have ones for deleting. And so for deleting and reading, since they're not necessarily modifying data, well, even though delete is, it's deleting the whole page, you only need the ID field for those ones as input. Whereas ones like create and update, there are more there because you need to add the additional information to it. And information fields here that have the exclamation point are required when you're using the server. So I'll also show you the backend database that it's connected to here. It's using MongoDB. You can disregard the database name. That's just because this is a test. And so you see here we have information for a patient connected to a SOAP node here. They're connected to each other via their object IDs. The object ID is automatically generated whenever it's created, and they're always unique. So that's how they find each other when you're querying the data. And so I'm going to go through that to showcase the read functionality, but first I'll go through the mutation ones. So you see we only have one patient file here. So let's say we want to create a new patient. Let's go about how you would do that. So start by saying it's a mutation, and what's nice about GraphQL is it autofills a lot of the information, and even if it doesn't right off the bat, you can hit Control Space and it will show you all your options at that point. So you see we can create, we can update, or we can delete. So right now we want to create a patient, and this is where you would input the information to be put into the database. So for the name, say he's Kevin, or Krevin. The age, we'll say he's 45, and gender, because gender is required here, say he is male. And we want it to return the specific ID because we're going to use this ID generated for the other mutation agents. So let's see, Got the patient ID here created for Krevin. And if we go back to the database and refresh it, he should show up. And there we are, Krevin, right there, male, 45, so it's got all the information, but it doesn't have any of the information that we didn't put into it. So let's say that we just forgot to input a few things. So now let's take his ID and let's modify his file a bit. Let's say patient, patient ID right off the bat. Input that there. Let's say it's been 5 years since he showed up, so now he's 50. And don't want to do that. And let's say he moved to Canada. Make sure that it's going right. Say we want to return the ID. And that should be age, not gender. Hit that. And we'll see, did it add a location and change his age? Yes, it did. He's now 50 and he lives in Canada. And the final mutation that will show is just deleting him outright because I just made him up. He shouldn't exist in here. That's not right. So I want to delete that patient, the patient ID. Is that there? And we'll still have it return the ID even though it doesn't matter at this point. Hit that. And you see Krevin no longer exists in the database. So you can see how the autofill of GraphQL and being able to see the documentation here, it makes it very easy to set up these queries for very specific information. And so the last agent that will show is the read functionality using the pre-existing patient that's in there. So we could use these read functions to view the entirety of the node, of the information in the nodes in the database, but we want to find information on a specific patient. So we have the ID there, and I'll just quickly grab this ID. So what do we want to know from this guy? We want to know his name, see his age, and we want to look at what's within the SOAP nodes. We'll organize them by date, and let's see what's in the subjective. Look at his family history. See. There, the objective, look at his lab tests, do that just to make it a little easier to read. In the assessment, what do we want to find? Let's just do main diagnosis, and in the plan, let's see if there was any follow-up. So we've set up our query with only the information that we want. If we go with it, then it generates that information and nothing extra that we didn't define here. So you see we got the name, the age, the date of that SOAP node. If there was more than one SOAP node, then that would go right after it. We got his family history, some alcoholism. When he came in, he had some lab tests for blood. Found that he was had some Lyme disease, but there was no follow-up or plan. That entry was left null in the database. So that's a general summary of how you can use the CRUD agents to navigate our QL4POMR server. And next I'll be going over what we're working on right now and what we're going to be working on over the next couple of months. Okay, so what are we working on right now? Well, one of our main focuses is implementing the other APIs in our proposed development stack here. As you saw in the demo, GraphQL and Apollo is what's used to create that front end, and it's connected to the Mongo database backend. But in the future, we're going to want to connect it to other databases like Neo4j. I'm not going to touch on that during this webinar because it hasn't been implemented yet, but that's coming in the future. What we're mainly focused on for the stack right now is the React API, and that's aimed at developing a more user-friendly front end. Because something you might have thought of during the demo is that this type of front end might not be as approachable to someone who's not quite tech savvy or doesn't have the time to learn how to generate these queries on their own. So using React, you would be able to generate a application like this, where you can still harness the capabilities of GraphQL, just in a way that's easier to understand for your average user. And generating queries could be done by something like this, where you just tick boxes for the information you want and give it a patient ID, and hitting submit, it would generate this query here using an algorithm. And then the information that's returned here would be transformed into an easy to read form here for the user. So that's one example of how React can be used as a more user-friendly front end. So that's something we're working on right now. Another issue that we're tackling right now is focusing these rather simplistic data types that are useful enough for representing hospital data at this point, but in an actual use case, they're going to be far more complex. And so in order to replace these simple data types, we're looking to map pre-existing complex data types that are standardized around the world. And we are using FHIR resources to do this. So as you can see here, what we had before with a patient resource is still in here. We have the name, the gender, the address, the contact, but this is far more complex and is able to contain far more information. Every time there's a little box here, it means it's connected to a different data type with its own information fields. So taking our simple implementations and instead replacing them with these complex resources will allow our QL4POMR server to become far more usable in an actual healthcare setting. So how we're going about mapping these FHIR resources to our QL4POMR schema is by using the schema already generated in this QL/FHIR server here. This server has generated the schema that can interpret FHIR resources into a GraphQL format without implementing any resolvers. So it's fully customizable and free to use for developers however they would like. So using those pre-generated schema, we don't have to create them ourselves, which might cause problems if we miss something or missed edge cases. And we won't be reinventing the wheel, and we'll be saving a whole lot of time using the resources in this server. And so how we go about doing that specifically is by taking these FHIR resources stored as JSON files. You see here we have some information for the name or the address, among other things. And it's interpreted by the GraphQL FHIR server and displayed using our QL4POMR schema. See here we have a SOAP node here with a field for patient, for subjective, objective, assessment, and plan. And the example patient file has been mapped to the patient part of the SOAP node. And so moving forward, we're going to be doing this for the appropriate resources for subjective, objective, assessment, and plan. And by doing this, we're taking our very simple data representations for healthcare and providing this increased complexity in order to be used in an actual healthcare setting. So that is what we're working on right now. So to summarize the benefits of using QL4POMR for physicians and care design, it provides a robust schema and relationships to semi-structured data types, and that in turn makes it fast and efficient to query the data when you define those relationships. And using GraphQL, it provides the flexibility to easily add these data structures into our POMR schema with a wide range of complexity. So that ends this webinar. Thank you for listening. If you'd like to contact me, you can find me at dsawyer@lakeheadu.ca. And once again, you can of course find my associates, Dr. Fiaidhi and Dr. Mohammed, at their emails as well. Thank you very much for listening.